Hi everyone, my name is Ciprian Stratulat, and in this video I want to talk about how and why to chain generators in Python. I am a co-founder and trainer at Iterators. You can find us at www.iterators.com. I've been programming for over 20 years. I primarily use Python, Ruby, and JavaScript nowadays, but I've written code in many other languages in the past. Python is definitely my favorite programming language though. At Iterators, we love everything Python. We offer practical, detailed courses that cover everything from basics of programming in Python all the way to data processing, data engineering, and the latest topics in machine learning and artificial intelligence. You can see some of our courses on the screen. If you enjoy this talk and are curious to learn more, definitely check us out at www.iterators.com. And now let's talk about generators. In this video, we will talk about chaining generators. Consider the code below. We're going to import the string module. And if you've worked with this module before, you know that it has a couple of very useful attributes. One of them is digits, which basically just gives us a list of all the digits. And ASCII underscore lowercase will provide us with a list of all the lowercase characters. So let's say that we want to create a generator function that looks like this, digits and letters. And we want this function to first yield all the digits and then all the letters in the English alphabet. We can, of course, do something like this. Let's go ahead and create this generator function, and then we can use this generator function in a for loop. So whenever we call this function, we know we're going to get back a generator object, which can act as an iterable. So we can use it in this for loop. We can say for C, or character, in digits and letters. So in this generator, we're going to print the character, and I'm going to specify a custom ending character. It's going to be a comma and the space. By default, print will use a new line character. So every single character is going to get displayed or printed on a new line. But just to keep the output a little bit more compact, I'm going to customize it and say, I just want everything on a single line. And there it is. As expected, this generator function created a generator that yielded the digits and then all the letters. As you can imagine, this is useful because sometimes we actually have several sequences that we want to generate. So this is one approach. This works totally fine. We have a for loop right here. This will keep yielding as long as we are in this for loop. And once this for loop finishes, of course, the generator function will resume code execution from this other for loop. So then we are going to enter this other for loop, and we're going to keep yielding inside this for loop until this for loop ends, and then finally the generator will complete. We notice the output is exactly that. So we're going to show all the digits, and then we're going to show all the characters. While we're on this topic, let me show you a cool thing about the print function. So the print function, perhaps you've seen this before, can actually be used to print a number of items at the same time. I could say something like print, let's say A and C, and this will print ABC as expected. So because of that, what we could write is something like this. We're going to put a star in front of the generator object. This looks a little bit weird. What does it mean to put a star in front of a generator object? We've seen this notation before. We've put a star, for example, in front of a parameter in a function, and that allowed us to collect all positional arguments in a tuple represented by that parameter. We also saw the opposite. So we can actually take a tuple or an iterable, put a star in front of it, and essentially pass in every single item in that iterable as a separate input to a function. That's exactly what's happening right here. So remember, generators implement the iterable protocol, so they act like iterables. We can actually put a star in front of them to essentially expand them. When we do this, essentially the print function is going to receive every single item that this generator function generates at once. And because, as I showed you, the print function can actually print a bunch of things at once, we see the result that we get right here. 0, 1, 2, 3, 4. So all the digits and then all the characters. So you'll occasionally see this thing. Don't let it confuse you. It's nothing new. We've seen this star before. You put a star in front of an iterable. So essentially what that does is it expands that iterable. It's almost like it unpacks it and passes every single item as a separate positional argument to a function. In this case, the function is print. That's pretty cool. As I was saying, this takes advantage of the fact that the print function can be used to print multiple items at once. So here's another example. You can actually indicate a custom separator, by the way, as well. By default, we get a space between each of the items, but we can actually use this keyword sep, short for separator, and let's set that to a dash. So we're going to get something like this. We can actually run the code above if you want. We can come back here and include the separator, and there it is. We're going to get the same thing, but with dashes in between. So this is interesting, but let's come back to this chained generator code right here. We're yielding from one sequence, and then we're yielding from another sequence, and it works out. Is there a better way to do that? We can actually do it slightly differently. We can can clean up the code by separating it into two generators. We have a digits generator function and then a letters generator function. So why is this better? Well, because it allows for greater reusability. We might have situations where we just want to yield digits, and we might have other situations where we just want to yield letters from the English alphabet. In that case, we can use one of these two generator functions. This would totally work. We can get two generator functions like this. So the first one yields just the digits. The second one just yields the letters. Let's go ahead and define these generator functions. And of course, we can use one of them. For example, I can print all the digits. Again, there's this star notation in front of what is essentially an iterable to expand that iterable, to unpack that iterable into individual positional arguments that are passed to this print function. If I run this, of course, I'm going to get the digits. I can do the same thing with the letters. Obviously, let's write it. Why not? I'm going to just copy it. Here we go. Letters, and we get just the letters. What if we want to use both of the generators above, though? We discussed the benefit to this approach. The benefit of this approach is that we can keep the digits and the letters separately, which means that this code is a lot more powerful. Sometimes we may want to just generate digits. Sometimes we may want to just generate letters. Generally, you want to make sure that your generator functions are cohesive and they're small. So they should do one and only one thing. Ideally, they shouldn't do too much. We agree, hopefully, that this is a better approach, but this doesn't solve our problem. What if we want to chain these two generators? We want to generate digits and then we want to generate letters. How do we do that? Well, we can actually reuse these generators. We can put these two generators together, again, back into a digits and letters generator function. We could write something like this: for D in digits, yield D, and for L in letters, yield L. In this world, we have both scenarios covered. We have both digits and letters as separate generator functions, but we also have a digits and letters, which allows us to combine the two, to chain the two generators. And this, of course, will work. And we can again print this using the same star notation that we saw earlier, and this will work. One thing I don't like about this code, of course, is this right here. For D in digits, for L in letters, it just seems like it's too simple. It's too repetitive. It almost seems like there should be a language construct for this thing, because it just seems like it would be very common. And indeed, there is one. It's called yield from. So here's the cool thing. If you have a generator, you can actually yield from it. You don't have to write your own loop. You don't have to turn it to a list. You don't have to do any of that. You can just use yield from and then just pass the generator object. In this case, digits is the generator function. When I call that function, what I'm going to get back is a generator object. And then we're going to yield from this generator object until that generator doesn't have any more data to yield. And then the execution of this generator function will continue to this other line, and then we'll start yielding from this other generator. So this is an abbreviated form of what we wrote here. You can totally use this thing, but as I was saying, it's just more code to write, and why not learn another cool Python feature? And there it is, yield from. Let me show you that this indeed works as I explained. So we get this digits and letters, and this is a generator function that chains a bunch of generators together. But notice how it's actually very, very short. It's a very brief function, and it's actually not too bad. So now we have the digits generator, we have the letters generator, and we have a digits and letters generator if we need to. Let's go ahead and print this, and of course we're going to get the exact same thing. Our code readability improved quite a bit. Not only that, but because we broke the functionality into smaller generator function, then we increased the reusability of the code we wrote. Let's scroll up and see where we started from. So way past this, we had just one function, here it is, which had two yield statements inside it. We had a for loop that was looping over all the digits, yielding those digits, and then when those were done, it was yielding over the ASCII lowercase, so all the letters, and it was yielding those, and that was fine. But as we said, there was a shortcoming we identified. This will always yield the digits and the letters, and there might be situations where we might want either only the digits or only the letters. So we improved that code by splitting that generator function into two generator functions, one that yields the digits, one that yields the letters, and finally we brought those back together using this yield from statement, which allows us to yield from a multiple generators. So we can chain them. We can keep adding to these if we want to add more generators to yield from. An alternative to using yield from is to use the iterators module. In the iterators module, you'll find a chain function, which pretty much does what the name says. So it allows us to chain a bunch of generators and yield from the chain. That's exactly what I'm doing here. From iterators, I'm importing chain. I'm still defining the generator function right here, and I'm yielding from this chain of generators. So this is the first generator, and this is the second generator. Now, a very important thing to do here is make sure that you remember to call the function. If you don't call the function, this code right here is actually trying to chain a bunch of functions, and that's actually not going to work out. So if we scroll down here, function object is not iterable. The chain function actually expects select iterable objects, and obviously functions are not iterable objects. What we need to do here is to make sure that we call these functions, and when we call these functions, what they return are generator objects, which are iterable. So let's go ahead and fix the code, bring back to what it was, and there it is. We defined the digits and letters, and once more we can actually call this generator function, get a generator, and then use the star to essentially get every single item from this generator passed in as a separate positional argument to the print function. The advantage of using the chain function from the itertool module is that we don't actually need to create another generator function just to chain these two generators. We could write code like this: for character in the chain made up of these two generators, digits and letters, we're going to print every single character, and we're going to end the line with a space so that we get the output a little bit more compact. And there it is. This works just as we expected. This is actually very useful. You won't always want or need to create this other generator function that allows you to yield from a chain of generators. If you don't actually need that function, no need to create it. You can just use the result of calling chain directly with the generator objects that you want to generate. The cool thing about chain is that all it cares about is that these objects that we're passing in are iterables. What we could do is, why not add another list here? So let's just say 1, 2, and 3, and this will work just like before. We have the result 0 through 9, which comes from this generator right here. So these digits come from that digits generator. Then we have the ASCII lowercase, these letters right here, which are generated by the generator that we get from the letters generator function. There's a lot of generators in there, and I have a funny way of saying generators as it is. I apologize for that. And finally, we have this list right here. You can see the outputs 1, 2, 3, and you can keep appending iterables there. So it really doesn't matter. The data type doesn't matter. All that the chain function expects is that those objects are iterables. In essence, what it wants is it wants those objects to be able to give it a reference to an iterator that it can use in order to get the items from the sequences that are represented by those various objects.